Greetings, my fellow descendants of Boyracho K-Pro, the one and only. But before I continue, do make sure that you do check us out on Facebook, on Instagram, and on TikTok. We come into Twitter at SciMasters_ZA, right? Please don't forget to like, comment, and subscribe to our YouTube channel. You know what we do. So today I'm tapping into something very close to my heart. I've done this before, but now remember we've elevated. Now we're on another level, another lane, right? So today we're going to be doing physical science. I've done a lot for English. Now I'm here, physical science and mathematics. So today we're doing physical science. The first topic in physical science, which is physical science paper 1, we are going to be talking about momentum, right? We are going to be talking about momentum. So what is momentum, right? A momentum, it is a vector quantity, right? When I'm talking about a vector quantity, I'm talking about something that has direction. Bear in mind, physics is one of my favorite subjects ever, like the second best, right? So let me introduce momentum, right? So momentum, you must first understand what is momentum and how do we define it, because there is 2 marks given for defining momentum. So I'm going to teach you how to define momentum, right? So remember, when you're writing a physical science paper, it will be your paper, right? It's written department, wara. At the back, there's what we call the formula sheet, right? You go to the formula sheet, right? You go and check for the formula of momentum. The formula for momentum is momentum, right? This is the formula for momentum. The formula for momentum is mv. So it's usually written like this: P is equals to mv, right? Why did I say before I wrote P is equals to mv, I wrote momentum is equals to mv? Because I want to show you that in physics we can use the formulas. We can use the formula to define a certain concept, right? P means momentum, m means mass, v means velocity. What is momentum if you're smart? Momentum is mass times velocity. But when I won't say times, when you will not say times, what are you going to say? Check this out. When you are now going to say its momentum is, remember in grade 3 they used to teach us about something called if you want to say multiply, you say product. If you want to say plus, you say sum. Hence we have sum of something in mathematics, right? You see these things when you're dealing with patterns, right? In mathematics paper 1, right? Where if you want to say subtraction, you say something like difference, right? The difference between 2 numbers, right? So product is another way of saying multiplication, but in another level, in mathematics or in a scientific manner. So momentum is the product of mass and velocity. Perfect. This is how I used to define it when I was in grade 12, and I'll get 2 marks, right? So before they ask you a question in physical science, they are going to ask you to define the concept in most cases, or to state its laws. Well, it works with Newton's second law a lot, right? So you must know how to define a concept before you tap into it. Physical science is very easy, 3 marks. You just have to be smart, right? Check. Now that we know how to define it and we know the formula, the question is, K-Pro said momentum is a vector quantity. A vector quantity, don't waste your time. There's a scalar, there's a vector. Go back to your grade 10, right? Mass is a scalar quantity. Momentum is a vector quantity, right? Which means momentum has direction, right? And what does momentum, how does this whole thing work, right? Sharp. So first, let's talk about proportionality so that you can actually understand what is going on, right? In mathematics, that's what I'm saying, physics and mathematics. If you're a physics learner, you probably do mathematics, and I hope you're working with me because I'm going to add a lot of maths into this. Sharp. Check. Remember, this is our formula. P is equals to mv. Alright? Sharp. So this is what we call P is equals to mv. Perfect? This is still our formula here. Right. Now, check. What we have to do now. With this formula, we must also understand what we call proportionality. And remember, I'm still introducing this topic, right? So I'm trying to make sure that everything makes sense, right? We have what we call proportionality. Now, proportionality now is the one that is going to tell us what this momentum actually is. Now check. Proportionality means now the proportion. What you must know, or what you must cram as a learner, is that momentum is directly proportional. It is directly proportional. It's directly proportional. Right? To mass. And it's also directly proportional to velocity. Perfect. Right? So now, what does that tell you? It means that guys, physical science is so easy. I just don't even know how. This is the easiest subject alive. It's like mathematics. Check again. So this is what's going on. The higher when the now the higher the mass. Let's put it like this. The higher the mass. I'm talking about directly proportional to mass. When I'm saying it's directly proportional to mass, I mean when I'm talking about proportionality, I mean that the higher the mass, the higher the momentum. So for example, if they were to say the mass maybe is 8, and then on the other side P is equals to 10 V. Which one is going to have a higher momentum here? Obviously the one that has 10 is going to have a higher momentum. Why? The momentum will be higher. Why? Because the mass is more than the one with the 8. The mass this side is 8. This one will have a higher momentum. So momentum, the higher the mass, the more momentum. Sharp. Now I'm explaining part 2. Directly proportional to velocity. Right? What does that tell you? The higher the velocity, it's the same thing. The higher the mass. Right? But now there's something that I want to teach you about the velocity. The velocity now, right, also controls the direction of the momentum. Physical science is so easy. The velocity, why? I want when I explain a topic, all of you guys understand what is happening. Don't just go into the questions without actually understanding the logic behind that question, right? So check. Let's become scientists now. V, right, is velocity. V is a vector quantity, right? M is a scalar quantity. It has no direction. It only has magnitude. Sharp. Momentum, I said it is what? It is a vector quantity, which means it must have direction. But now, remember, mass is a scalar. So mass cannot give us the direction. So where are we going to get the direction, the final direction of the momentum? We are going to use velocity to be the one that guides us what the direction of our momentum will be. If you have questions, please drop on the comment section. I'm killing it. Sharp. Now that we understand this whole logic, someone might ask, how do we do it? How do we do this whole momentum thing and whatsoever? It's very, very simple, guys, right? It is very, very, very simple. But always remember that the momentum will always be in the direction of the velocity. Wherever the velocity is, the direction of the velocity, that's the direction of the momentum. It will never change. Because what the momentum is doing is that it says mass doesn't have, mass is a scalar quantity, it doesn't have direction. So I'm going to use this one, which has direction. Right? Sharp. Perfect. So in the next tutorial, we will be doing questions or practical examples of how to solve a momentum, step by step, step by step. So what you can do for me, just to subscribe, like, and comment on the YouTube channel. Shout out to everyone out there who's watching our tutorials. Peace.